Hi, and welcome to the Vaadin webinar. I'm your host, Marcus. Today, my guest is a Google Polymer team member and the creator, at least one of the creators of LitElement and LitHTML, Justin Fagnani. Welcome.
Hey there. Thanks, Marcus.
So today, we're going to be talking about the next generation of the Lit technologies, LitElement 3 and LitHTML2, if I got that right.
Mm-hmm.
Now, if somebody just happened to stumble into our webinar not knowing what these are, could you give a quick 30-second overview of what we're talking about today?
Yeah, so like you mentioned, I'm part of the Polymer team, and we've been working on web components, for a number of years now. And what we try to do is help people build web components and use web components. And so LitElement is really an evolution of Polymer as our base class for building web components. And it basically helps you do the most common things that you need to do to build an element. So templating and data binding, reactive properties that will update your component, dealing with styles and things like that. So that's the main thrust of the library.
Excellent, yeah. And I'm sure you're going to go a whole lot deeper into that once we get to your part of the presentation. Now, before we get there, just want to remind everyone to ask your questions in the comment section of whatever platform you're watching the stream on, and we'll try to get to as many of those as we can towards the end. But before handing over to Justin, I wanted to give just a quick introduction to how Vaadin fits into this whole web component and Lit ecosystem, just to help kind of give a little bit of context on why we're interested in talking to Justin in our Vaadin webinar here. So depending on how you've gotten to know Vaadin, you might know it as one of two things. You might know it as a web component library. So we have a big library of these web components that you can customize the look and feel. And the idea is that we want to give you this big library of ready-made building blocks so that you can build your app faster without having to kind of build all the building blocks that you then build your app out of. Now, if you've been using Vaadin for a longer time, you might also know it as a Java framework. So our history actually is in the Java ecosystem. We've had a framework for Java developers to build web apps for the past 20 years already. It's always been a component-based framework. Initially, essentially, what we did was we transformed an XML transform to generate your UI based on things running on the server. That then turned into an Ajax adapter that we built in-house that then turned into Google Web Toolkit, or GWT. And then just a couple of years ago, we decided that, hey, we have these cool new web technologies coming out in the browser, allowing us to actually define these components, not as kind of a bunch of divs taped together, but actual HTML elements that the browser can understand. And we've now just recently released a new framework that uses the same set of components. So just as an example to give you an idea of what these are, let's take a look at how we could build this kind of data grid showing just a couple of pieces of information from a person object. Now, if we have a backend that looks like this, so this is Java code, this is running in a Spring Boot server. We have a service class that just has access to a repo of basically a database, and it exposes one method for finding everything in the database. We've added an endpoint annotation there and a service annotation, which will allow us to access the same endpoint now in two different ways. So the classic way we would do this is in Java. So this is the classic API that we've had over the years. So you would create a new grid by instantiating a grid object in Java. You tell that you're going to be working with a person object, and you add whatever columns you want to map on that object, and then you call set items or you call set items with all the items from that service, and that would give you that grid. Now, the new framework that we just recently introduced is Vaadin Fusion, and here we use LitElement as the templating technology. And by adding that endpoint annotation in the Java class earlier, what that did, in addition to exposing that endpoint, it also generated TypeScript types that match the Java type. So you can see here we have a internal property, which is a array of person, types, which is imported from a generated folder. We also have this find all accessor method, an asynchronous TypeScript method that we can call that's imported also from a generated person service. And then we can bind to a Vaadin grid, in this case, a HTML tag with the items property set to that array of people. So you can see it's fairly symmetrical in kind of how it works. The big difference is that Flow, the Java code that runs on the server, whereas obviously the Fusion code here runs in the client. So this way, depending on what type of app you want to build, you can use that same set of components. And if you're a Java developer, that really kind of helps you be productive. And finally, the thing that we're working on in the Lit ecosystem is a kind of code-first visual editor that allows you to kind of live preview what you're doing in your Lit template. So if you're building out something, you can kind of quickly see that things end up where you expect them to, and hopefully save some frustration by not having to kind of go back and forth with between your browser. So this is something that we're building out. We're adding a lot of features where you can kind of select back and forth, have all kinds of templates and snippets and stuff that really kind of help you build apps with this quicker. All right, so that's a quick introduction to how Vaadin fits into the whole Lit ecosystem. So we have the components that are built with web component technologies used by both of these frameworks, and then the new Fusion framework specifically using LitElement as its templating language. So I think that's a good introduction from me for everyone to get an idea of what we're talking about. So Justin, I'll hand it over to you if you want to share your screen. I assume you had some slides for us.
Yes, I do. Let me get that going here. Share this.
All right.
Okay.
And I can see your screen here. All right.
All right. Whoops. Let's not get ahead of ourselves there. Okay, so I'm going to give a little update here on what's new with Lit. So we're going to be releasing some new major versions. So I want to go into what we're going to have in those. So first, before I get into the new versions, I want to give a little bit of history for those who might not know like how Lit came about. So Lit's actually been around for a few years now. The first prototype we made was right when Polymer 3 came out in mid 2017. And we talked about Polymer 3 and Lit HTML together at the 2017 Polymer Summit. And then we worked on the prototype and had people using it and kind of changed the API shape quite a bit, from feedback, and then added LitElement 2, and finally got to these initial releases of LitHTML 1.0 and LitElement 2.0, which we had to do 2.0 because we got the NPM package name from somebody that had already used 1.0 in there. So that's why the version numbers are different. So that was in early 2019. And things have been pretty stable and good since then. We've kind of had some minor additions, tweaking perf, continually improving that, working around some browser issues, but basically things have been pretty stable. And now we're coming up on a new set of releases about 2 years later, LitHTML 2.0 and LitElement 3.0. And I kind of want to get into like why we created Lit, like what we got out of it to show you what we're going to do next. So to do that, I'm going to go all the way back to Polymer 2. And Polymer 2 was based on HTML imports. And it had a HTML-based template syntax. So this was kind of natural if your component definition, like your single file component, lived in an HTML file. And so you had, let me get my little, laser pointer, my favorite feature here. Yeah, so we have a template here, and inside the template we have some expressions. And these expressions are Polymer expressions. They might look a little bit like JavaScript, but they're not. And then at that time when Lit came out, we also released Polymer 3. And the big change with Polymer 3, it was essentially the same code as Polymer 2, but the big change was that we moved the file format from HTML into JavaScript. And this is around when browsers were supporting JavaScript modules natively. So we could stop using a whole polyfill, the HTML imports polyfill, and have no polyfills required at all for all modern browsers at the time of Polymer 3. But what that required us to do, because we were in JavaScript, is we had to use these template literals in JavaScript. And we put this little HTML tag on here that didn't really do anything in Polymer. But we discovered that code editors like Atom especially automatically triggered on the name of this tag here and would syntax highlight this. And so we were like, okay, that's kind of nice to have syntax highlighting. But the expressions down in here are still Polymer expressions. So they're not exactly JavaScript. They have some kind of features that might look like it, like dot property access. But so that causes some dissonance maybe with developers. The big negative downside for us was that since it's not JavaScript, the JavaScript tooling doesn't see those expressions. So we don't get any kind of hover docs or code completion, or if you're using TypeScript, you don't get type checking on those expressions. So lit was basically a natural kind of extension of this, of us saying, okay, we're in JavaScript, and we have template literals. Let's change the template system so that we can use actual JavaScript expressions in the $ curlies. And this gets us a lot of benefits, especially in terms of tooling and compatibility and whatnot. But it changed up the template system a little bit. We lost two-way data binding and we got one-way data binding. But in general, we had a lot of benefits. It was smaller because we didn't have to carry around an expression parser and evaluator. It was faster because the expressions are using just the JavaScript parser and VM to do the job. It ended up being more powerful because we moved all the control flow into the JavaScript layer. And so, our templates now are just JavaScript, and you could do all kinds of interesting stuff with, you could use for loops and while loops and switch statements and put sub-templates and function calls. So it became quite a bit more powerful. And in the end, I think we had a better DX. I know there's a lot of people who like HTML templates, but it was, something that you had to learn specifically in Polymer. And, we always felt basically that, the role of a component is basically to merge data and DOM. And that ends up being a lot easier when you do that on the data side of things, because you have, access to JavaScript imports and utility functions. So we thought this was a nice improvement, and I think the community has felt that too, and LitElement has gotten great uptake over the past couple of years. So that's where we got to with the first versions, right? And so now we look ahead a little bit, and we kind of wonder what's going to be next for things. And we opened up some issues in the repos, asking, kind of giving out our ideas for things and asking for feedback on what people had for ideas for the next major versions. The biggest thing is SSR support. People have been asking for that for a while. But there was a bunch of stuff around cleaning up the API. Directives were a little difficult to write. People wanted directives that could clean up subscriptions and stuff. And people wanted like spread bindings and a bunch of features like that. But for us, SSR was kind of a primary thing. We started looking at all these requests and kind of grouping them and trying to see if we could add these or if they would require breaking changes. And so we grouped things into a number of categories that we attacked when we looked at if we were going to do breaking changes or not. And it basically came down to like new features, better DX. We wanted some patterns to enable code reuse, which I'll get into in a little bit. We always want things to be smaller and faster. And of course, we want to be ready for SSR. So these are kind of the major categories that things fit into for the next versions. But in order to get some of these things, we did need to make some breaking changes. So we don't take that lightly. We have seen the cost of having breaking changes in terms of migrations. But some things we needed to do, like for SSR, we needed to reduce the amount of customization that people could do for templating. So we removed what we call the template processor API, which it turns out almost nobody used. So this isn't a breaking change for many people. We wanted to remove some browser bug workarounds. Safari had a bad template literal implementation years ago that caused us to do a slow thing. And so if we remove that, we're faster. We want to add package exports for modern module CDNs like Skypack. But none of these things are major breaking changes. So the big idea that I want to get across here is that these are minimal breaking changes. This actually, for most people, should be a drop-in replacement. There are definitely some small API changes here or there that we wanted to make, and we took the opportunity during these releases to do that, but we kept a very small break and change budget. We are also taking this opportunity to publish even more modern JavaScript. This helps us have smaller payloads to browsers. And then directives, we really wanted to change the directive API. So that's kind of the biggest breaking change here, is how those are written. But just to show you how small of a breaking change is, this is admittedly artificially simple, of an example. So it doesn't use all the features that might change, but this is a lit element in LitElement 2.4, and this is the same lit element in LitElement 3. And basically nothing changes. I mean, if you're not writing directives and you're not doing things like awaiting calling this request update, some small things like that, you're actually not going to have to make any changes. Okay, so let's get into the new features then. What have we added here? The first thing that's kind of small but very nice are what we call element expressions. So in Lit 1, there are two types of expressions. There's attribute expressions and text position or child node position expressions. And attribute expressions have to have an attribute name. And so we were able to rework our pre-processing step to support expressions on an element that don't have an attribute name. Right now, they can only take directives, so there's no kind of value you can pass in that will just be rendered to the element. But they're really great for attaching behavior, and you used to have to make up an attribute name to do this. So here's an example with a Vaadin feature here. Vaadin has this directive that helps do some form validation, and it's called field. And currently, they have to make up an attribute name like ... in order to apply this directive. And what that's going to look like in the next versions is you're just going to have an expression there on the element itself. And the nice thing is you can have multiple of these. So if you have different behaviors that you want to attach and compose onto an element, you can do that via the element expressions. Next thing up, this is one of our oldest bugs, is static expressions. So the way HTML works is it separates the static template from the dynamic values. And it turns out that for some very kind of dynamic and advanced use cases, that sometimes you want to be able to dynamically create a template. That is, you want to fill in the parts of the template that are not getting new values updated into them. And an example of this would be like having a dynamic tag name. So you can't actually change a tag name in the DOM. You have to take an element out and replace it with a new element with a tag name. But for some systems, they want to be able to kind of dynamically create elements with tag names like that. So we figured out a way to do this by having an overlay module on top of LitHTML. And the way this works here is that you import HTML and this new unsafe static wrapper from a new module called static HTML. And once you do that, you can use unsafe static to produce values that you can put in all kinds of weird positions in your template that you didn't used to be able to put bindings. So here you can see that we put this tag name value inside of the tag name position for an element. And this was completely illegal to do in Lit 1.0, and now it's possible in Lit 2.0. There are a lot of caveats here. It's definitely unsafe. If you put user content into here, you could easily create an XSS vulnerability, which Lit is usually pretty immune to. So that's something to be aware of there. Okay, now the biggest change in terms of API changes, not additions, are directives. So in Lit 1.0, directives are functions, but they're a little hard for some people to grok because you have to have they're actually function factories. You have to have an outer function which takes your directive parameters, and then an inner function which is the directive callback itself. So we were able to clarify this a bit, I think, by making them classes. And we get a couple of important things here. The first one is that the directives are naturally stateful. So when we see a directive expression, we'll create an instance of a class and store it with the rendered DOM for you. So now you can just keep state as class fields, and you used to have to do complicated things to keep state. And the other is that we wanted to make directives naturally SSR compatible. So we gave them 2 different lifecycle callbacks instead of 1. And the first one is called render, and you're supposed to return server compatible values. And then the second one is called update, and it's only called on the client. And in update, you can access the DOM. So a real quick example, here's a lit 1.0 directive. You can see that we have this double function cascade thing here. So this directive doesn't take any parameters, and then it produces a function that gets a lit part, and now it can do stuff imperatively to that part. And it could also access the DOM associated with that part. What we do in Lit 2.0 is we turn this into a render method on a directive class. And you'll notice this looks a little bit like you're making a LitElement component in a way here. And then you pass it through this factory, which produces a function, and that function will give instructions for creating an instance of this class when it's used. And where this becomes really nice is when you have statefulness. So here's an example of like a counter directive. This is going to render basically whatever content you pass to it plus how many times it's been rendered, how many updates you've had. And in order to keep this state of how many updates you've had, you have to, in lit 1, basically like keep a weak map around and key your state off of the part that comes in, and do this, get the state from the weak map and initialize it if it wasn't there, and then update it if you need to, and then finally you can return the value here. And a lot of our built-in directives had this pattern. It wasn't so bad if you're used to it, but it's definitely not as declarative or obvious as we would like. So in Lit 2.0, this becomes a class, and Lit creates the instance of the class for you and keeps it around. So now the state that you need to keep can just be a class field. So it's easy to declare and easy to initialize. And it's also easy to make this work on the server. So here we're going to render any content that was passed in. So you can use lit HTML expressions like right in your render. So we're going to render the content here and render the initial count. And then when we update, we get to do dynamic stuff. So we're going to update our state and then just return the render result again. So we think in general, this makes things a little more clear in terms of the state and the update behavior for directives. And the key part for us, SSR kind of drove the entire effort here for these new versions, is that we can run render on the server. This doesn't have any access to the DOM, and it kind of returns a declarative value. So what we wanted was that to give a pattern where by default directives would be SSR compatible. Okay, and then we had some requests, longstanding requests for the ability for directives to kind of be notified when they're connected and disconnected from the DOM. So we created a additional subclass of directives that let you do this. So they have a disconnect and reconnect callback. And they can also update template values outside of the normal render lifecycle. And these are really, really great for things that might need to clean up subscriptions. So think observables, anything like that, where if the DOM you rendered goes away because the element went away or some conditional rendering took it away, you want to clean up all those observers and free up that memory. So this is a different base class because it has a little bit of cost in order to kind of register itself to be removed. So we wanted this to be opt-in. But here's an example. And I actually don't know RxJS that well, so I just kind of like cobbled together some code. I don't know if this fully works here, but the idea should be clear enough, is that this is an example that takes an observable as a value, and it's going to subscribe to it in update. And so I'm not sure exactly what, say, Angular might do for SSR, but here is where you would implement SSR if I knew what to do with observables there. But what you do is when an observable comes into your update function on the client, you can subscribe to it. So here we're going to get the subscription with the normal RxJS API. And in that subscription, we're going to call setValue. This is an API on async directive that lets you update the DOM directly. So now we have an observable that when we get new values is going to update our template. And then the key to doing the cleanup is that we have a disconnect callback that'll be called, and we can unsubscribe. And then it's highly recommended that if you implement disconnect, it's possible that some DOM will be reattached at some point. Say if you're using it in some cache template. And so when you reconnect, you can resubscribe. So this was a big feature asked for a long time, and we have this now with async directives. And I had some highlights I didn't show. Okay, that's kind of the biggest breaking change right there, is how directives are done. And then the next thing is the biggest addition, and one of my favorite things about the new versions of the library. So we're calling this reactive controllers. So reactive controllers are a new code reuse pattern. They're fairly simple. They're really just objects, but they let you do a lot of stuff that you would see in things like React hooks or maybe the Vue composition API. And what they are is they're basically reusable partial component definitions. They have their own state and their kind of own identity. You new them up, they're an object, and you just hang them off of your host component. And so that's how they stick around. You just see them in normal class syntax. And they're a little bit like a headless component. So they don't have a render callback. But what they can do is they can hook into the host component's lifecycle. So LitElement now has an API on it called add controller. And it will call into any controller that's added that way for things like update and updated and connected and whatnot. And the controllers can also trigger a host update. They can just call request update on the host. And importantly, they maintain their own state because they're just an object. So they're actually very simple. They're defined as this interface here, and they have 4 lifecycle points besides the constructor. And these are just called from LitElement when the host hits these lifecycle points. So you have connected, disconnected, update is before render, and updated is after render. And one thing we're trying to do here too is, not lock things into being LitElement specific. So we have defined what we call the reactive controller host API here. And all this requires of a host that wants to be able to utilize controllers is that you can add and remove a controller. And that defines the contract that the host also has to be able to call those lifecycle methods. And then you have request update, which is going to cause a new update of whatever that host is. And you have update complete, which you can wait for the next update to finish. Now you notice this doesn't extend LitElement and it doesn't extend HTML element. So you can have reactive controller hosts that are not necessarily attached to the DOM or require the DOM. So a controller could just be very abstract in this way. You could even have a host in React land, which I'll actually get to later. But here's a very simple controller. This one is a mouse controller. So this one listens for mouse move on window and refreshes the element when the mouse moves. So to show how this works, so you can have some state, you generally always need to store your host, and you have some state you care about updating. In this case, it's the mouse position. And what we have is an event handler here on mouse move, and all it does is update the controller state and then tells the host to update. And so now the host can re-render and access the new state. And then to make sure that we do things properly and don't leave event listeners hanging all over the window for elements that might be disconnected, we add the event listener when we're connected, and we remove the event listener when we're disconnected. And I am going to, and then this is how you use it. So you just new up the controller and you store it on your elements class. And then you use the state from the controller in your template. And the nice thing here is that the controller takes care of abstracting all of the logic that tells the host to update. So you don't actually have to wire these together. Basically, you create the mouse controller and then it's ready to go. And it tells your component to update. And I have a demo of this right here. So that's just that code you saw there. And LitElement updates very fast and only updates the parts that change. So it's nice and responsive. Okay, back into the slides. So controllers are exciting to me for many of the same reasons why hooks are exciting to the React ecosystem, because they provide a very easy way to abstract other APIs and hook them into the component update lifecycle. So you can imagine lots of uses for this. So mouse and keyboard input, like I just showed there. Asynchronous tasks. Controllers can run a task and update the host as that task progresses and completes or errors. You can imagine wrapping resize observers and intersection observers so that they automatically tell your component to re-update. GraphQL and other state management things are really nice to put into controllers. Yeah, any kind of network I/O you could do through a controller, and it will update your component. And then animations and transitions, which I think are very exciting, and I'll get into in a little bit. I'll probably skip over this a little bit, but I did want to point out that we have, oops, let me get back to my laser pointer. We have a new area, new NPM org that we're going to be using for not exactly experiments, but labs stuff, where it's like we want to get feedback on it before we release it as like a new core library. And one of the things we have in labs is a task controller. And this kind of goes back to some talks I've given about how to structure applications with Lit and how to make things more declarative. And so what we do is we have a task controller where, given some task function and some dependency data, the task controller is going to run the task function and then update the host as that task completes. And you can see that we can use the task controller down here in our template, and we actually get different callbacks for the different states that the task is in. So as the task is pending, we're going to render one template. And when the task is complete, it's going to give us the data and render another template. So this should make dealing with all kinds of asynchronous operations a lot more declarative and a lot easier. And then, of course, if you're vending a library, you can do things like subclass this task template or make a new factory that does a specific task that you have, and you can vend those out to your users. And then we get to the thing that's probably most interesting to me, or at least the most fun to demo here, is that you can combine directives and controllers to do some really interesting things in your templates. So a directive can be a controller. And this means that when your directive class runs, in its constructor, you can get access to the host element and call add controller with the directive itself. So now your directive may have callbacks for the template being changed and for the host render lifecycle to happen. So this means the directive can hook all of the normal lifecycle of the host, connected, disconnected, and render. And the really important thing here that directives couldn't do before is that the directives now can do work before and after render. Directives used to only run during render. So if you wanted to say like measure an element before the render, before you started changing it, you couldn't do that before, and now you can. And where this applies really, really nicely is with doing animation and transitions. So if you're not familiar with the flip animation paradigm here, Paul Lewis, Chrome DevRel, popularized this a while ago. And the idea is that you can express animations in this pattern pretty regularly. And what you do is you figure out your animation start state and end state at first. First, last, invert, play. First, the thing you're going to do is you're going to measure the thing you want to animate. And we have a callback for that now in host update. Last is the last state of the thing you're going to animate. Well, we can measure that after the render. So after you've rendered the new state. But we get to go before there's actual paint here. So then what we can do is we can apply the inverse styles and basically move the element back to the initial state. And then we apply keyframes, which are going to animate that element into the end state. And the nice thing about this, combined with directives and element expressions, so this kind of ties three new features that we have in, is that you can have a template here. And so here's just some component that may have some items, and it just has a repeat and renders those items. And just by putting an element expression with the flip directive on the items, you can now get them to animate from their old position to their new position, even though they changed position in the DOM. So this also combines the fact that repeat is keyed and keeps DOM stability. So I want to show this one real quick. Yeah, here we go. So this is that code from the slide I showed you before. It just renders 4 items. And it's using repeat, so the DOM elements stay the same, and we just threw the flip directive on them. And so now, I don't know, it didn't animate the first time. There we go. Maybe the shuffle didn't happen. So now when we shuffle them, you can see the elements slide into their new positions. And Steve on our team has been working on this flip directive, and it has a lot more power than just moving the elements around. You can specify what properties you want to transition and your easing functions and what to do when elements are removed and added, fly in and fly out kind of stuff. So there's a lot of power there, but we're trying to make it very declarative and very easy to just drop that power in on your templates. All right. So that's basically it for the new features there, but I think it all comes together really nicely in that flip example. Next, let's talk about code size and performance. So throughout this, we wanted to add new features, but we're very, very sensitive to code size. Lit is known for being small. People want to use it for sometimes individual components that are not part of a larger app or design system, and so they don't want their small single-use component that they want to share with people to be very big. So we've actually been able to reduce code size and increase performance while adding these new features. So first, Lit HTML 2.0 is 34% smaller minified and 18% smaller minified and compressed. So we're back under 3K for gzip, and we're like at 2.5K for Brotli. So I think these are very good size numbers for everything it does. And then it's even better on LitElement. On LitElement, we're actually 40% smaller minified and 27% smaller gzip and Brotli. So this should be very good for small, minimal components and apps that want to have less code to parse and less code to send over the network. So we're very happy with these results here in light of the new features. And then on the benchmarks, we've been able to get faster too. Some of this is from using more modern JavaScript, removing the customization APIs, and some browser bug workarounds. And it depends on which benchmark you run. We have a suite of them, but I think you can see between 5 to 20% faster on initial render, which is particularly important. And our updates are already really fast. And I think you can see between 7 to 15% faster on updates. And last here, I want to talk about SSR. So SSR kind of drove the whole process here. Even though we're gearing up for new releases of LitHTML and LitElement, we're not actually going to release production-ready SSR framework just yet. So the big thing is that LitHTML and LitElement are ready for SSR. They have hydration implemented, and the hydration modules are going to ship with the new versions. And like I mentioned with directives, all the built-in directives are server compatible already. And we have a node server implemented. We basically have a function that will render a lit template, including all the lit elements in it, to a stream. But our current demo server and code is using like experimental VM modules and a bunch of stuff. And we just have some work to get that production ready and to try to get some testers using it. But real quick, the goals of SSR, we're being pretty ambitious to kind of go to what the cutting edge of SSR implementations have right now. So our SSR server does streaming. So if you think about a template literal, it has strings that are there already. It kind of is striped from string to dynamic value to string to dynamic value. And so we use a generator and we send the strings directly to the HTTP server as soon as we can. And that's important for getting very low time to first byte and getting the browser rendering the page fast. It's also incremental. So you can rehydrate different subtrees of the page independently if they're lit elements like in the main page. And then lit HTML on the template side, we make sure that it doesn't do any DOM mutations at all if you hydrate it with the same data that you server-side rendered it with. And it's also interoperable. The core server that we have basically has kind of plugins for different template languages and different web component base classes. We only have LitHTML implemented, but we should be able to see kind of going back and forth between, like, it'd be great to get stencil working in there or something like that. And then also full fidelity. So we want to keep shadow DOM scoping and all the semantics that you have if you did client-side rendering. So we're utilizing the declarative shadow DOM proposal in web components and a polyfill there. And so, hopefully that moves along and we'll be able to use that natively to boot up a full shadow DOM page in the browser with no JavaScript. And so that kind of brings us to the summary of what the new releases are all about. They're smaller, they're better, they have more features, they're faster, and they're server ready. So this is kind of our little Daft Punk inspired mantra here. And I can lament Daft Punk breaking up as I mentioned that. And then one more thing I wanted to mention. So I mentioned that we have this Lit Labs NPM org where we can try stuff out before it's finalized and get feedback on it. And one of the things that we have in Lit Labs right now is that task controller. The other thing that we have right now is we're working on framework interop. So, the main kind of benefit of web components is this idea that they work everywhere where HTML does. And so if you look on a website like Custom Elements Everywhere, you can see that most frameworks have very, very good interop ability with web components. The one that stands out as not having great interop is also used the most, and that is React. So we really want to, have a lot of empathy for both the component authors and the potential component users. So we know a component author wants their components to be used and usable in as many places as possible. And a potential user of those components doesn't want to have to jump through hoops in order to use them. So we are experimenting with a couple things for framework interop. The first one is a factory that turns a web component into a React component. And the way this works here, is that you can import this create component factory from Lit Labs. You import your element from wherever you have it. And then you call the create component factory with an instance of React. This is what we have to do because React doesn't ship as modules. The tag name that React is going to create when it creates your component, the base class that you actually need to instantiate, and then a little bit of a configuration so that React can add event handlers. So we typically implement events by calling dispatch event and just assume you're going to call add event listener. And React doesn't work that way. So this will kind of create properties on the React component in order to add event listeners. And once you do that, you're able to use that component in JSX and in React, just like you would use any other React component. And we will eventually make sure that ties in with SSR as well. So you can have these components SSR in like Next.js. We've been experimenting with things like that too. So that's a big thing there. What we hope is that component authors who want to provide a React version will basically just have a module like this sitting next to their component, and they can just tell their React users, if you want to use this component, import this other module, you get a React component. And then finally, controllers are a lot like hooks in many ways. A controller gives you callbacks that are very similar to what you would get if you used use state and use effect and use layout effect in React. And so it turns out that you can actually write a controller host for React, where the controller host uses React hooks to instantiate and call into a reactive controller. And this isn't landed quite yet, but we have it in a PR where we have another factory here where you can write a hook. So this is going to be like that mouse controller I showed before. And this is a React hook. Inside of that React hook, you call this use controller hook and you give it a factory. And this factory is, when it needs to, it's going to create a new reactive controller. And then out of your hook call, you can return the controller itself or return some state. You can kind of massage the API here to be idiomatic for React. And once you do that, you are able to use your reactive controller in a React functional component. And so we hope that this means that the controllers can actually be used by people who want to share these kind of reusable code bits across frameworks. You can imagine maybe making hosts also for Angular and Vue and whatnot. So we'll see what happens there. I'm kind of interested to see how that plays out. Okay, finally, when is this all going to happen? Not right now, but soon. We basically have all the code finished here, and we're working on a new website. We're doing a unified website between LitHTML and LitElement now, and we're trying to get some feedback on how the new versions, especially things like using ES 2020, how that works in people's existing tool chains and whatnot. So I can't give a date, but we're furiously working on this to try to get it out the door soon. And that is my update there. So yeah, Marcus, hopefully we have some questions.
We sure do. Thank you. That was awesome. I think Jared put it very well here. So better performance, new featured, improved DX pick, all three, mind blown. Overall, people seem to be pretty stoked about the new release. Lars was saying that he's going to flip all his elements in his enterprise app now that you are shipping this. So overall, yeah, I think people seem to be super stoked about all of these things. So thanks for that. I know I'm at least super eagerly waiting for all of this to land. And I know you have a pre-release out that people can already start using right now if they want to.
Oh yeah,
that's try
actually
it out.
Kind of a huge oversight on my slides is I didn't put the npm install instructions on there. But yeah, so both LitHTML and LitElement have tags that are called next-major. So you can do npm I LitElement at next-major, and you'll get the next version here, and you can try it out. The docs are not in a great place. Like a lot of the stuff I talked about there are not visible in the READMEs or the docs yet. So you have to kind of go hunt around to try that out. But at least, like I said, it should be a drop-in replacement for most people. So you could kind of verify that that's the case.
So what does the upgrade process look like for a normal project? Say I have a small Lit project right now using the previous current major version, and I want to try out the new one. I install the new version. I guess I update some imports and that's it, or?
Yeah, you shouldn't even need to update most imports. So there's a couple of things I left out here. It's a lot to fit in this time. So one thing is we moved polyfill support into a separate module. So if you're supporting IE, next to your web component polyfills, you'll have to load in this thing we call platform support or polyfill support. Yeah, and then other than that, a lot of the imports stayed the same. We have some small changes where request update doesn't return a promise anymore. Some of the LitElement callbacks, the more rarely used ones might be a little bit different. But mostly the imports stay the same. Yeah, so
okay.
Unless you're writing directives, hopefully there's not that many breakages here.
Yeah, and I think that's kind of obviously we as a framework vendor will have to update some of our directives, how they're implemented. Like you kind of showed a little preview what that might look like, but at the end of the day, that shouldn't be a very big change for anyone just using what we ship or what you guys ship. So that's really good. You mentioned that SSR was really one of the big driving forces behind you wanting to do this upgrade. Do you want to speak a little bit about what parts of SSR were kind of the driving factors? Was it performance, SEO? I guess you're using LitElement pretty widely at Google for different things, and you get requirements from projects within as well.
Yeah, I mean, the Google thing is interesting because Google Stack is very different and very Google. So SSR at Google, ends up being like a compilation to another language, which then runs on Google servers. So inside we have this linter, which restricts you to a subset of JavaScript that we can translate to this other language and run on our Java servers. So that hasn't actually driven the open source SSR uh, requirements that much, because on
Hmm.
open source we actually have a lot more freedom, as people typically run node servers to actually execute the JavaScript. Um, I do think we should document our technique that we use for Google, because so for Vaadin, you have customers running Java servers, and it would be great to
Yeah.
SSR there too. So yeah, we have that kind of thing working internally. The biggest thing that's driven the new versions from SSR is that in some ways, LitHTML 1.0 is more of a template system construction kit than a single template
Hmm.
system. We have these APIs that let you customize how templates are interpreted, the template processor and the template factory APIs. Um, and these let you change the binding syntax and like wrap values and create different types of parts. So you can do all kinds of weird stuff in there. Um, and the problem is that when you're SSRing, the way we SSR is we kind of drop into the DOM some markers about, oh, here was an expression. Oh, here was a template that was rendered. And we'll drop a hash, like a template ID for that template. And so when we go to hydrate, what we're trying to do is reconstruct the data structure that the template had right before it was rendered.
Yeah.
So a lit template is going to be like a tree of template expressions and values. And we can reconstruct that tree if we assume that you didn't use any of the customization APIs.
Yeah.
So at that point, it seems like we might as well get rid of those customization APIs, drop a little code weight, and gain some performance. So that was a big motivator for this.
Yeah. Makes sense. Um, then I had another question, kind of more of a personal question that I've been wondering every once in a while. So you said that you're going to ship a unified page for LitElement and LitHTML. What do you like? What do you call these things together? Do you call them lit? Do you have a unified name when you're just talking about the lit technologies as a whole?
Yeah, I mean, we're gonna kind of be rolling that out over the next weeks or months or something, like as that stuff is ready. So yeah, we are working on like an official, I know colloquially people call this stuff lit a lot. Um, we're gonna try to work on like the official name for what we call this stuff
Yeah.
collectively. And I think the website launching is gonna kind of give everybody that. And I know people have
Good.
been asking for us to have a logo,
That was going
and
to be my next question.
yes, we're finally gonna have a logo. We actually do have a
Nice.
logo already. It's just super, super duper top secret right now.
Yeah. No,
We're in the process.
it's kind of a silly and small thing, but at the same time, I noticed talking to people, it's like immediately when you give something a name and a logo, it's much easier to kind of talk about it. It's much easier to understand kind of like what is this compared to React or Angular? Like, how does it fit into
Yeah.
this? You don't have to kind of dig into all the small details.
Yeah, I think we saw that in like the Stata.js survey too. LitElement was in there for the first time this year, and you see these tables comparing everything. And we've kind of been pretty low key with LitHTML and LitElement, and that's part of the reason they didn't have a logo and didn't have a unified name.
Yeah.
But now I think we're seeing a lot more usage and a lot more of these comparisons against frameworks. So it'll be good to have that kind of tightened up a bit.
Yeah. All right. Well, let's go into some viewer questions. We had Nelson here asking about template instantiation. So with the old Polymer templates, it was kind of easy to give your select or grid or other thing that repeated a template. Kind of, you could just give in the template tag and have that repeat. And his question is there kind of a declarative way of doing that? Right now, what we're doing in Vaadin, and I guess in a lot of other places, is we kind of pass in a render function. But yeah, any thoughts on that?
Yeah, I mean, this is a great question. Even in the Polymer days, yeah, even though you could pass a template in, it was always a Polymer template, right? So it's pretty tied to Polymer semantics and having the host element be a Polymer element. So if you're willing to make that coupling here to require that the user of the component understand the framework you wrote it in, then like you said, passing in like a render prop, like a function that uses lit-HTML is quite easy. You can't do it from the HTML side, but you can do it from the JavaScript side really nice. We have seen people do this pattern where they invented their own simple template language to pass in. Like Microsoft uses LitElement for their Microsoft Graph elements, where you can kind of query the Microsoft Graph SharePoint kind of database that they have. And so you can like query for users and render a template across those users, and they do that with a template element and some expressions. I think this is something that we should work on kind of as a community. One thing we've been trying to do is start up these community protocols in the Web Components GitHub org, where we can collaborate on cross-element protocols for doing stuff like this. And it'd be nice that even before template instantiation, it would be nice to be able to say, like, you pass a template in with an attribute that says what template processor you're going to use to like evaluate the expressions, and the element you pass it to is able to like look that up and render the template, something like that.
All right. Another good question here. Hot module replacement. I had a feeling this one would show up. So any news updates to this story with Lit3?
Yeah, so it's not forgotten. Lit3 actually gets a little better here. Another thing I didn't mention is that we have added a dev build and a prod build to the way we distribute the packages. And so we use npm package exports to let users select between the dev and prod build. And this means that we can stick more stuff in the dev build without impacting prod sizes. And one of the things we can put in there is the code that was required to get LitElements to re-render. So we had a PR against LitElement 2 that kind of patches it to work with hot module reloading. But there wasn't yet a standard for the hot module reload callback for modules. There was for CommonJS with module.hot. And so now I think between Snowpack and Vite, I think they have kind of converged on an import.meta.hot callback. And so we should be able to put those pieces together and have hot module replacement for Lit3.
Excellent. We got a question from Westbrook on the Polymer Slack just before we went live. He kind of was comparing or kind of looking at reactive controllers and comparing them to hooks, and kind of how hooks in the React ecosystem really gained a lot of traction just because of how big the ecosystem is, and a lot of people started building them. And he was kind of wondering, like, how can the Polymer team and the community around kind of help build out a similar kind of ecosystem, I guess, of controllers and cool functionality that all. Yeah,
and I think there was another aspect to Westbrook. He was kind of asking like how to avoid lock-in around that too. So the first thing is that I think that being able to make these really easily reusable bits of code that wrap, really useful APIs and drop them in and take care of all the connection to the element lifecycle. I hope this is just going to lead to like a Cambrian explosion of these controllers, and we're just going to see a bunch of useful packages out there that let you hook your elements into things. And then, like I mentioned, that like the actual API for controllers is not tied to DOM elements or custom elements at all. And so hopefully people write these controllers so that they don't assume LitElement, right? And then that means we should be able to write adapters to other frameworks. And I showed that React adapter there too. And I think if you look at the basic React hooks, right, use state and use effect are probably the two most core ones. Use layout effect, they consider use context a core one as well. Those correspond to lifecycle points that basically every framework has, right? Like mounting and unmounting and, after render, during render for React is just when you call the hook itself. So I'm pretty confident that we're going to be able to write hooks and hook adapters that will work across lots of frameworks. And to me, write controllers that work across lots of frameworks. And, to me, in a way, I think controllers, they're simpler, right? They're just objects, and they have some state and some behavior. and they don't require as much of like an infrastructure to have, hooks have this kind of action at a distance thing where the hooks have this state that's stored and controlled somewhere else, and you basically need a hook system in order to be able to drive the hooks. And with controllers, basically the state is just properties on the object, and the lifecycle is driven from the element pretty directly. So like the implementation in LitElement for adding controllers was really like one line per lifecycle callback to call into the controllers. So I hope, it's pretty presumptuous, I guess, but I hope that like we can see some things be distributed as controllers so that they can work across all the different frameworks.
Cool. The question about adding attributes to the host element in a declarative way. I was actually something I was looking into a little while back as well. Something like
yes.
adding class names or whatever else attributes.
Yeah, so right now we essentially recommend you do this via reflection. And there's an interesting like philosophy of web components question here too, is that, in a lot of ways, the component itself should not be writing to its own tag.
Yeah.
Right. Like its tag is owned by the parent component that is controlling it. But we still have reasons for styling and accessibility and stuff why we need to do this right now. So we're going to look into this. We had prototyped a attribute template type in LitHTML2, and that would be like, just the attribute and property bindings, but no tag, and you could put it onto an element. And that would be nice to use for host attribute bindings, because you could have a callback called like renter host that returns one of those things. The only problem is it was a little bit too much code for our budget. So we're going to come back around to this in a point release probably.
Yeah. All right. Well, it seems like the discussion on the chat has kind of diverged into discussion about swag and plush Justins, and if there will be a store on the new Lit site where people can buy their new stickers and hoodies and whatnot. So people seem to be super excited about everything coming out. I think we'll start wrapping up. We still have a couple of questions, but we'll try to answer those in the chat afterwards. And thanks a lot, Justin, for joining us. Super exciting stuff that you have coming out. Waiting for that, and definitely going to try out the pre-releases. And maybe you can add a comment to the video just where people can find those, so anyone watching this will be able to find those and be able to try them out.
We'll do, and we'll have a blog post where we have some easier to use docs around those pre-releases too. All right. Yeah, and thanks a lot for having me, Marcus. This is great.
All right, and thanks everyone for watching, and tune in next time for our next webinar. Bye.